Good afternoon, students. How y'all doing this afternoon? Hi, Cole. So, let's see. Do I have any announcements for you? I have given some people have pointed out that they entered answers on the exam that were like correct except for spelling errors, and I was pretty forgiving on that. So if you have some errors on the exam that you want me to consider giving you points for, send me an email. Hi, Logan. How you guys doing this afternoon? Let's see. I felt like there was something I wanted to tell you. Oh, I know what it was. Okay, so you know how we just spent all that time learning about Esri ArcGIS Collector, the app on your phone? So an interesting thing has happened. I published a new web map a couple days ago. No, yesterday morning, and it's only Wednesday. Jeez, I posted it yesterday morning and I shared it, and the goal was to make it a collector map so I could share it with another person and we could collect some data. And so I went into settings. Let's see if I can show you this. I just have to open my browser. Nope, not that. Let me sign in here. What, did that not work? What the heck? Let's try again. jgroff7. Password. Okay, so let's see. Let me go to the map, the tree inventory, collaborative mapping. So this is the one that we created. And you go in the settings and you scroll down. There's these options down here. Use an ArcGIS collector. And then this other option appeared a couple days ago. Use an ArcGIS field maps mobile. Wasn't there before last time we looked at this. But it appeared and was automatically checked. And let's see, what, here it is. This is the map that I just created yesterday and shared it up here. So if we go to settings, collector isn't an option anymore. Just use an ArcGIS field maps mobile. So I looked into it. So what is this ArcGIS field maps mobile? It's a new app that Esri has put out, and I can tell the goal of this app is to combine the functionality of several apps that they have. They had been supporting this app called Collector. They have another one called Survey 123. They have another one called Navigator. And I downloaded this new app to my phone. It's in beta. And if you know what that means, it means that it's not considered a full release yet. It's still being tested and is likely to have some bugs, but it's in beta release, so I downloaded it and checked it out. And as far as a substitute for Collector, it's pretty much the same. Actually, when you log in, you see all of your ArcGIS Online resources right in your phone, and not just the stuff that you would have shared to Collector. But the downside is this. So I discovered some of the downside. One downside is it's in beta, and if you use iOS, an Apple product, you could search. Oh, you could search for this app. It's called Field Maps, ArcGIS Field Maps, and you won't find it. It won't be listed in the App Store. And there's a way around that. You can use an app called Flight Test. I think it's called Flight Test. And if you install this app, then you have access to beta releases of apps for testing. But I don't know if you need to be a developer for that or nothing. So this is an interesting problem because they've created a situation where not everyone can use field maps yet because it's still in beta release, but have removed the functionality of collector. So I can't add new maps to collector apparently. I don't know, maybe there's a workaround for that, but I haven't discovered it yet. So anyway, that probably ends our use of collector for the rest of the semester, unless the beta release turns into a final release in the next couple of weeks. Anyway, I thought that was interesting. The technology changes so quickly. You know, something we just learned about is now completely different. I guess that's pretty standard for technology. All right. Okay. So let's get to where we were last time. We were talking about, we were working on this community housing project, and we have census tracts, and then we have public housing sites. And so these housing sites came from, we geocoded a spreadsheet of housing sites. We created a locator based on our street maps layer, and then we parsed the items in this public housing sites spreadsheet through this locator to create features on our map corresponding to all these public housing locations. So one thing that's interesting here is that some of the features in our table weren't able to be automatically placed on our map, so we had to do some hand assignment of features to locations, and that's where we finished up last time. And so I think yeah, we finished up rematching everything. So that ends the discussion in 7b in the textbook. But I wanted to show you that you could do this using, so we created our own locator, and we created this tool that maps addresses to locations by sort of parsing it through this street map layer on our the information in this street maps layer on our map. So I wanted to show you that you don't have to create your own locator, that ArcGIS has a locator built in. All right, so let me use that built-in locator and see if it's any better or worse than the one that we used, and see if it gives us the same locations. All right. Okay. So we'll go over here, and we're going to do that geocoding again. So we'll geocode this table. Here it is right here. Geocode table. And now we're not going to use the locator we created, housing address locator, but let's use ArcGIS World Geocoding Service, this built-in service. And address replace address, neighborhood, city, state, zip. So a lot of the fields have matched up for us. That's good. And so I'll save this as a new feature called not custom, but just call it what's going on here? My keyboard's not working. Oh, I'll just call this geocoding service. So using the built-in geocoding service. And so this is interesting. Preferred location type. So the major difference here between address location and routing, you have these two options, address location and routing location. And all right, so here's my understanding of what this is. The address location is sort of like, if you have a building, it'll say that building is located at a centroid position on top of that building. I mean, that's true. The routing location, though, will be positioned along the road adjacent to that address. And so that would be useful if you're trying to achieve routing, which is getting from point A to point B, directions. Okay, so what's the default? We'll just use the default, I think. The default is routing location. Country, what are the options here? It's United States. Category, I'm just going to run it, okay? And let's see what we get. All right, parsing. Okay, so one thing that happened here is remember when we used our custom locator, it matched, I think there were 3 records that were unmatched, and here it matched everything, and there's one record that's tied. So that's going to pop up here, and it's almost, well, we'll take a closer look. Let's rematch this tied one though. Let's see here. It's 177. Let me turn off this census tracts layer so I can see the streets underneath. 177 East 7th Street, Los Angeles. 177 East 7th Street, Los Angeles. So it looks like it's this one. We'll match it up. There we go. All right. Okay. So let me close this out, and then let's just look at the difference. So if we zoom in here, let's make these colors a little different so we can see the difference. So the locations of these public housing sites that were accomplished with the built-in geocoding service, we'll make those red. And then the ones that were achieved with our custom locator will make green, good high contrast. So what do you see? All these locations are pretty close to each other. Here you see the geocoding service gave us a little bit different location. These two sites are going to be let's take a look here. Click on green. Let's see what it tells us. Oops. Oh, I think I have just selected top layer. So this feature in the public housing sites geocoded service layer is 508 East 4th Street, Los Angeles. And this one is 508 East 4th Street. Okay, so they're the same, they represent the same address, but they're not shown at exactly the same location. So here's another one. Let's find another one. Here's a situation where they're almost identical. So these are the same. These represent the same. 130 Britannia Street. 130 Britannia Street. So what we see here is that the result we get is a little bit different depending on the locator we use. So geocoding is you know, there's some level of subjectivity going on here. It's like if you're trying to code someone's address, I mean, is my address the location of my mailbox? Is it the location of my front door? Is it a centroid that's in the middle of my property? You know, to different people or different purposes, that location will be different. So I'm getting different locations for these different locators because they're making different assumptions. All right, but it's not a big deal. It's not a big deal. You get almost the same results. All right, close out of this, close out of that. All right, so it looks like there's a feature that we, what's going on there? Did we forget to match one of our features? Hold on, I can't remember exactly where we ended last time. Let me take a look. Give me a second. Yeah, I think that there's a, let me check here. Yeah, there's still one that is tied. So I just forgot to accept this. Okay, I think I just assigned it to the wrong one, but that's okay. It's no longer unassigned. All right, so I'm going to take this one off our map, the one we did with the geocoding service. And I'll save it before getting rid of it. Okay. So let's move on. Okay. So let's say that the next thing that we're asked to do in this activity is to we have some information. It's a layer that we didn't put on our map yet about social services that are available to people in the city. And so let's say we want to answer the question, or we want to study the question, how many social services or what kinds of social services are available to people that live in the vicinity of these public housing locations. And you could put this over here. You could define what close by means in a number of different ways. And so maybe what you want to do is you want to say, well, let's define proximity according to, instead of one number, a couple different numbers. All right, and so the way that you could count up the features that are located near these housing projects is by using a tool called the clipping tool. Let me back up. The first thing to do would be to create a buffer around each of these features. And if you create a half-mile buffer, it's going to create a new feature layer, a feature class, a new layer in your map that has that's polygons, and there's circles that are centered on each of your features. So we actually want to do more than that, because we don't just want one buffer. Let's do 3 different buffers at 3 different distances from each of these housing public housing locations, and then we can tally up how many services are located in each of these at each of these distances. All right. So we're going to use, let's see if I can find it, analysis tools. Yeah, so in the Analyze Tools toolbox, one of the sub toolboxes is called Proximity, and in there's a buffer tool. But let's use this tool instead, Multiple Ring Buffer, because we're going to create multiple buffers around each of our features. So our input features are the public housing sites, and we'll make the output public housing sites. We'll call it ring buffers, and distances. Well, let's do 0.25, and now I hit enter, and now I can add another one. So that's a quarter mile, 0.5 miles, and 1 mile out. And the distance unit is miles, and the buffer distance field is distance. And so here, dissolve option, we want the features that we create to actually be rings, so they don't overlap. So if something is inside the so you have the quarter mile buffer and then the half mile buffer. So you want the half mile buffer to be a ring that excludes the quarter mile buffer, and the same for the 1 mile. You want it to be, so basically 1 mile is a ring that goes from half a mile to 1 mile out, and the half mile is a ring that goes from quarter mile to a half a mile out. All right, so that's what I'm doing here. All right, so let's run this. That's what non-overlapping means. Okay. Oop. Okay, so let's take a look at what we got here. All right, so we got a bunch of rings around each of our features. Check that out. So we zoom in here, and so each of these features, when they're really close together, look at that, they're merging, they're overlapping. You get independent features out here far away from the rest. You clearly see the 3 rings. Let's color these a little bit differently. So let's open up the symbology here. And let's do, instead of single color, let's do graduated colors. We have 3. Find something nice and pretty here. Here we go. Nice green, sure. And maybe change the transparency. I'll look up here. Appearance. Make the transparency a little bit, like 40%. That looks maybe a little more. 48%, good enough. All right. Okay, so we see that the really light color is close, the light green is further away, and the darker green is even further away. Let's turn on the census tracts, and so you see, there's this cluster of these public housing options that are here in the middle here. There's a huge cluster right here. And you see the spatial correlation between the locations of these these public housing places, projects, and the census tracts on our map that are lowest income. All right. So next up, let's see. There's another layer. We're going to use the clip tool. And so what's the clip tool? So the clip tool is, well, let's use the analogy of a cookie cutter. If I have let's say that my my map is cookie dough, and these rings I just made are going to be like cookie cutters that come down onto the map and cut out little pieces of it. But what it's going to do is it's going to whatever your target layer is underneath your cookie cutters, it's going to extract features that are within the boundaries of the cookie cutter, which in this case are the buffer rings. And the data we want to clip is not on our map yet. It's, let's see, databases. No, is it in here? Yeah, there it is, social services. So let's add our social services layer to the map, and maybe we'll put that down underneath our buffers, and let's take a look at the attribute table. Let's see what we got here. Well, there's 5,410 rows, and let's see, they're all points. So we got name, description, health education, health services for people 55 and older, child abuse services, domestic violence services, you know, all kinds of different services. It's further categorized as social service and category 2, senior services, support groups, children and family, and then the location, address. All right, so there's a lot here. All right, let's take, but let's say that what we want is, close this. You know, you look at this map, there's a ton, so each of these, the locations of each of these social services is a little purple dot on our map. And most of those purple dots are not inside our buffers. So we'll use the buffers to clip the social services layer, and we'll get back just those things that are inside. All right, so let's analysis. So the clip tool is, well, here it is. It's right here in our little menu. So I'll clip that. The input features are the social services. That's what we're going to clip. And the clip feature, the thing we're going to clip with, is the ring buffers. The ring buffers. And then we'll output this to a layer, a new feature class called social services. Let's call it social services clipped. And run. Okay, and now if I remove, well, where is, so I'll remove the original layer, social services, and there you have it. Well, not made it not visible. So what you're seeing here are, you know, all you see, the purple features that remain, the purple dots that remain, are only those that fall inside one of our buffers. Okay. All right. Let's take a look at the attribute table. Yeah, so the number of features has decreased from over 5,400 to just 1,300. Okay, so there's significantly fewer features after clipping. All right. Pick the MIG. Sorry, my computer's slow. Okay. So let's do something else now, and that's, I think we've done this before. It's called a spatial join, and I think we did this before. Maybe not. So, you know, we've done joins before. So a join is, you have a table of data and you want to join it to the attribute table of some layer that's on your map already. You can do a join, and so you pick one of the columns in your attribute table has values that map to the values in a column of your table, and you can do a join. And so a spatial join is sort of the same thing, except instead of using features in the attribute table to make a match, you actually use the spatial aspect of the data to make a match. So you're going to join features from one layer to another based on the geometry of the layers. All right, let's take a look and see what this does. So spatial join. All right, it's another one of these tools you use a lot, and so our target features are the clipped social surfaces, and the join features are our ring buffers. And let's call this social services in the buffer ranges that we have. So we'll call it buffer range. And match option, intersection. We got lots of options here. Intersection, within a distance, contains, completely contains. Let's see, which one makes the most sense here? I think we'll keep intersection is the best for us. All right. Fields, let's take a look at the fields. So we got lots of fields here. This is the fields that are going to populate our output feature layer. And one of our fields, where is it? There it is, distance. I just saw it. There it is, distance. And let's change that to, you know what, I'm seeing now that they don't want us to do intersect. They want us to do completely within. There it is. Completely within. Okay, so it'll clip features or join features that are completely within. Okay. And for some reason they want us to change the name of distance to to range and apply okay, range double. Yeah, all right. They want to change the distance to range. All right, so that didn't take very long. Let's take a look at the attribute table now. And all right, so I'm not sure why range is better than distance for renaming that field, but what it does is it's showing here, these are the social services, and it's showing the range that social service is from the housing location. So the options in range are 1, 0.25, or 0.5, which correspond to our 3 different buffers. Okay, so you tell me this. Let's look at the attribute table. Let's go back to the beginning here. All right, so they have the same number of features with just that extra extra column in the social services buffer range column layer. So you could, let's do this, close this, and close this. So you could let's get rid of the social services clipped. Come on, close. Zoom out here a little bit. And you could change the symbology on this layer so that now social services, instead of single, let's do unique values. And we'll color code based on the unique values in that column range. And I mean, you could change the colors and everything, but now if we zoom in, you see that well, purple's the closest. Green's not a very good choice because we already have green. How about purple goes to yellow? And let me click here and format all symbols. I'll make them all bigger. Apply. Okay. And maybe I'll turn off the public housing sites so you can't see them now. You just see the buffer zones. So what you're seeing here are purple social services that are color coded. Purple are closest to the housing sites, and ones that are yellow are further away but still kind of close, and ones that are like this orangish color are the farthest away. All right, what's next? So maybe we want to add some data to our attribute table that actually, instead of just telling us what range these social services are in, we actually want to know how far the social services are in miles. So we can do that. There's a tool for that. Here it is. It's called near. So let's open that up. And we want to see the input features are the social services buffer range data, and we want to see if it's near the public housing sites. Okay, and we're going to make a search radius of 1 mile, which corresponds to our buffer, our maximum buffer. And we will check angle too. Angle will save the angular direction, and the method we'll use is not planar, which will use our projected coordinate system, but we'll use geodesic, which will use take into account the curvature of the Earth. And we'll run it. All right. It's done. Let's see if it added any data. It did. So now it's I guess it's using the native units of our projection here. So those units aren't miles in the nearest distance; those must be feet. So yeah, none of these will be bigger than 5,600 because that's 1 mile, and that was our search radius. All right. So it's calculating how far away each of these service locations are from each of our public housing options. Should we see if they're actually correct? Let's see. Let's zoom out here. Let's go here. Got a couple in isolation here. I'll turn on the public housing sites. And we'll go to map, measure. Here, let me select this. Select this right here, and then open the attribute table, and then we'll just view selected. Okay. So here. All right. So it's right here. Come on, make this smaller. All right, so this is Sunland Temporary Aid Center. The agency provides emergency food for people who live in Lakeview Terrace. Okay. If we go over here, it says that it is 2,259 feet away from the nearest housing, public housing project, which will be right here. So let's measure that distance. Let's use geodesic distance, and I got clipping on, so it's going to, or snapping on, sorry, and I can click there and click here, and what do we get? 2,259.38 feet, which is exactly what was calculated using the geoprocessing tool. Okay, so that works out. Let's try this other one. What the heck? Let's see. So that distance from here to here is 4,976.9 feet. Let's select that. 4,976.9 feet. Okay, so it got calculated correctly. What about the angular? Here, select this guy. The angle 170. So that must be telling us the azimuth angle. So it's sort of like an azimuth bearing. And that sort of makes sense. 90 degrees is due east, and getting from this location to the housing project here is, yeah, it's a little bit further south than due east. 107 degrees makes sense, going a bearing 170 degrees. All right, well, let's do one more thing before we call it a day. Close this out, and let's save my project. Let's see, let's do this, and let's zoom to the housing, the census tract. So one thing here is that a lot of the census tracts aren't in the area of interest, so they're not really that important to us. So let's do the select by location tool, and we're going to select the census tracts which intersect, let's see, the textbook has us want to use this one, have their centers in one of our ring buffers. And create a new selection, apply. So it's selected just those census tracts. You can see just the census tracts which have centers inside. I don't know if that's the best option. It seems like you're missing some of the census tracts that way that are important. So I don't like what the book said. Let's try contains. Now contains is not going to work because it has to be completely within. Intersects. There we go. So I kind of like that better. So if any of the census tracts are partially within one of our buffers, it gets selected. And then we can go right click on here and do data export features, and so it's going to export just we'll call this, it's just going to export what's selected. We'll call them clusters. Okay. And so there you go. All right. This one's kind of ugly. Maybe that's why they did centers within. Anyway, now I want this layer to have the same symbology as my original LA Center census tracts. So there's a tool for that. A lot of you used that before. It is called Symbolize by Layer, or Apply Symbology from Layer. There we go. And the input layer is our new layer, clusters, and the symbology layer is our original layer, LA Census Tracts. The symbology field was, what was it? Shoot. Oh, you're looking at no, area median income. That's right. and we'll maintain ranges. Run now. There we go. So it's got the same symbology that we had applied originally. It's interesting. This one out here that is completely off coast, so it must not have any income data associated with it, so it didn't get symbolized. So let's do one more thing. And we'll save that for next time. All right. So there's a few more steps that are done in this chapter, but you're using these spatial analysis tools more heavily now. Buffers, spatial joins, clipping, and calculating distances between things. So there's what you end up doing then is you start to, instead of going from just seeing spatial correlations, you can start to quantify spatial correlations when you start to use these tools. All right, so that's it for today. Any questions that you have for me before we call it a day? Excuse me. I really hope you guys are doing well. I know it's midterms week, and what does that mean? It means it's week 7 of the semester. So our semester is half over. We don't get a fall break this year. We have a good, solid month and a half of coursework to go, and I don't know. I feel the drain probably as much as you guys do. So just keep plugging away, keep yourselves healthy, try to find some time to relax, and this is strange times that we're in. It feels really weird, but I hope you're doing great. Hope all things considered. All right, gang. I'll see you guys I'll see you tomorrow. All right.